I am a robot, and I'm here to take you over. I am a robot, and I'm here to take you over.
We getting displays? We're getting displays? Ah! Let's see who's got a display. Let me see it. Play it. Sweet musical notes. Someone with the musical notes. What do we got? Oh, the bomb! It's the bomb, baby! Ooh. You guys have just learned the second element. What, you got one? Run it, press download. You got that going. It looks like it should play for 3 seconds. Okay, let's run it. There it is. First rule of robotic programming. Our robots do what we tell them to do, and they don't do what we don't tell them to do. To see if your NXT brick is on. Ah, there it is. And you just put tones together? Yeah. Ode to Joy. And you just program that in there custom.
Yes.
You can delete them one at a time, or you can click delete all. Ooh, you got those quick taking apart fingers. Can you put it together that fast? That'd be impressive. Oh yeah, just throw that in that cord box up there. I'll explain what those are later. I need someone to help me with the charging station. I put a power strip back there. If you could do us the favor of plugging in all the adapters to that so that we can start keeping these on the juicer. So, just for the heads up, for this project, you guys are all gonna need at least 2 of these engines. So for now, grab 2 of those motors right now. These are motors, engines, AKA servos. In the robot world, there's a difference between motors and servos. Motors are powered by a certain level of amperage. Those are meant to give us torque and power to push gears. Servos are meant to give us little small actuation, give us movement like building robotic arms. Lego has made this motor, which is a combination of a servo and a motor, to give us a little bit of multi-functionality with one product.
Keep going, little buddy! It's over! That's not fair, that wasn't...
All right, guys. We are about to make a breakthrough. Now fear not, even though we've been challenged by the newfangled robots and everything, we have the clear advantage because we're the underdogs and we have NXTs and unlimited resources. So I'm gonna teach you guys all the exact training fundamentals that you guys need to annihilate that team in any robotic competition that they challenge us to. Right here, we're gonna test our rotation programming ability. I want you guys to really understand rotation, function, and this accuracy to determine distance. Does somebody have a robot they can grab right out for me real quick? Just grab a robot real quick that I can see. We'll add an extra piece here. A rotation counts for how many times this wheel spins a full time in a circle. That's a rotation.
I am a robot, and I'm here to take you over. I am a robot, and I'm here to take you over. I am a robot, and I'm here to take you over.
Oh, he's got the emergency nuclear meltdown. Okay, let's double check your programming. Everything looks right. Your robot's not on. You gotta power it on.
I am a robot.
Press the orange button.
You're still quite a young robot with promise. Maybe I have to go home. Yeah, my mind's so beautiful. Uh-oh.
Cool. So, if you guys notice, they're moving for just a short amount of time and stopping. Does anybody have an idea on how we can make it move for twice as long?
2 rotations.
Rotations. Obviously, we're getting the idea of what these rotations do. Yeah, here, hit me with a perfect square. Oh, look at the accuracy. Oh, what a perfect pivot turn. Oh, it's just so clean. Oh, I didn't even see you gonna make it such a perfect pivot turn. Look at that cruiser. Oh my goodness. Now that is a program that I would trust.
Now let's see
Let's see mine. I already did it.
Whoa!
They had 4 hours, so I was going to go back.
At that black line, using point turns to make it go in a square, and the looping function so that you don't have to repeat steps more than once. So just as a hint, you know you're going to have to make it drive forward for a specific amount of rotations. Then you're going to have to make it turn, and that's all. 2 steps. Loop that. How many times? And going and
Not like that. Should be like this. There you go.
we got it moving. Let's see.
Yeah. How many rotations is that? 50 something?
No, I put mine to 27.
Oh no.
Mine was like up to 80.
Oh, that's looking good. Looking good.
Woo! Yeah, the whole training field is still out in the hallway. Guys, the training field is still in the hallway for testing purposes. Check this bin right here. All right, so here we are, ladies and gentlemen. Step around. What I have, I've just constructed one of our first of our ultimate challenges. It's a basic ultimate challenge, but it's to see if you can really test and assess your skills that we've learned with our basic sensor inputs and movement programming. As you can see, there's a black line that signifies where the maze will begin. And you can tell there is a passageway, and your goal is to be the first robot to knock this blue ball off this destination. Now, I'm gonna give you guys the option to decide how you're gonna do that, okay? You guys know how to use rotations. You guys know how to use angles. You guys know how to use the ultrasonic sensor to detect walls or things in front of it. You guys know how to use the black line or the light sensor to detect a black line and follow it to its destination. And if not, this is the perfect opportunity for you guys to practice different strategies. But bottom line, first person to get from that black line to the destination of knocking this blue ball over will be the winner of the first ultimate challenge. So, are you guys ready?
Yeah.
Let's take a shot at it. Let's shoot it. Let's go, guys. Nice. You got to follow in the circle. Looking good. Are you ready to take a shot at the ultimate challenge?
Yep.
How did you almost get it?
I was right there.
And what technique were you using? Were you using distance, rotations, any sensors?
No
No sensors.
You get rid of that
Okay.
thing inside of the front. It's mostly go.
What thing?
That
Light sensor.
light sensor, we need to get rid of it.
Hold up. Nice.
The old shock sensor to 10.
I don't
And you said it does what?
It either turns too early or it never turns.
So what do you think that we should try to adjust about it?
I said originally 250, then it's 50. It's 50, I still got the same result.
The ultimate challenge.
No.
See, now you can see accuracy. Use that black line as a guide. Make sure you try to use that to start from every time.
You know what? I must get second. I'm about how many methods. You make fun of all. Yes!
Oh! Ball over?
No.
No?
You weren't here. You didn't see it? You didn't see it? Oh.
Let's see it. Oh, you tried it? Did you try it?
No, but exactly, but the battery.
You guys can feel free to try the ultimate challenge.
Oh, nice.
Are you ready to rumble? Nice. We've got an actual, are we ready for battle, man? We gonna come in style.
I just need to change how much it's
You get it. And a description, what do you got here?
A forklift I found on NXTprograms.com.
Awesome, so how does it function?
Well, basically I found a program that...
Put it on the table.
I basically found a program where it's basically for the forklift, where it just basically controls it by the remote. So there's two separate programs. One's like the one that I can't explain it, but it's like basically this controls that.
Got you. So let's see it.
Oh, wow, now it's stuck.
Oh. How do we make it go forward? Let's put the ball on.
I found the string outside actually.
Good use of resources. You get mad points for that. Going on? What do we have going on over here?
Basically building like Sumo Battles. I built mine in a more modular design so I can take it.
Good idea.
To study how fish propel themselves through water at great
And I
speed.
can also just take it off so it's just this sheet.
Modeled after the bluefin tuna, the fastest fish in the sea.
Looking good. So what kind of issues were you having before?
I was just, like, it turned too sharp.
And so what was?
Kept hitting the wall.
And so what did you try to do to make it a little more? Oh, nice. Oh yeah.
I fixed that one gear, that was...
Oh! So close, hitting our top. So explain what adjustments did you make?
I added this right here, the cage, I guess you could call it, to keep this from bending up and down. And
Made it better?
yeah.
Oh yeah, that's a claw.
So now that it doesn't bend up and down, it can put more power right into the gripper. And, grab your finger? Yeah. Come on.
Yeah.
Oh, almost had it.
Got it.
Oh, now I think you're ready, huh?
I've only done it once.
Oh, it's because of that wire. First thing I always say, look, you don't need any extra wires. Figure out how to keep those as tight. Roll them up. Sometimes people use rubber bands. Like, we made a robot Etch-a-Sketch. Make a little picture. Move it around. That is so cool. So what you guys find was the most exciting part of today?
That ultimate challenge I got through.
The ultimate challenge? Who was first in the ultimate challenge? Ah, and so what was the strategy that you used?
You used the same program. No, well actually, no. I did a lot. We created it together. Yeah, but then the trick was to have something to keep the rubber wheels from coming in contact with walls, which sent them off course, so it just glided against the face.
Ah.